Hello students, and myself Rahul from Mocktest4you, and we are here to start the very well awaited course plan of NEET and NEET 2021 in our focus. And you can see I have written down some of the key points regarding the NEET preparation on physics. So, whenever we go through the syllabus curriculum of NEET, we can at least go for one particular thing, that is the 19% weightage to the mechanics in NEET. The 19% weightage we can see in NEET for mechanics, and I have written the chapters starting from dimension and error up to the gravitation. So this particular concept that we have to go one after another, and if we think about the past 15 years questions of, initially it was AIPMT, now it is NEET. So whenever we think about this AIPMT or whatever it is NEET, then we must focus on one particular concept, that whenever we are going for NEET preparation, we have to concentrate on these three sections. One is the applications of dimensional homogeneity, the second case is dimensional analysis, and the third case is the theory of errors. So from here, if we want to give stress on this type of preparation, according to your study plan, you can see how many classes are there. So whenever we are going to prepare for NEET, you know the chapter is, you know the what are the chapters content, but we need to revise a little bit for dimension and error, this particular thing, that units and measurement. We know very well there are two types of quantities in terms of dimension. One is dimensionless and the other type is with dimension. So whoever it is dimensionless, you know without any introduction, the dimensionless quantities, the quantities which are dimensionless, can be written as M0, L0, T0, and obviously within the third bracket. Now, any dimension, why I am writing in terms of these three? Because we know there are some fundamental quantities which are independent of everyone, which does not depend on any other physical quantities like mass, like length, time, like temperature, like electricity, there is electric current, and the mole, the quantity of any substance, and the luminous intensity whose unit is candela. So this kind of things are known as the basics or fundamental units. Now when we think about the fundamental units, the dimensions of them also becomes the independent one. So the independent dimensions what we get, there is mass, length, time, temperature, current, and luminous intensity and mole. Though in case of physics the application of mole is not that much for the case of dimension, but it is there. Candela also, that is the luminous intensity is not that much used, but the most important five parameters will be, that is mass, length, time, current, and temperature. Mass, length, time, current, and temperature. And here I am introducing that M for mass, L for length, capital T for time, theta for temperature, or even you can write it for capital K, which is starting from the concept of Kelvin, and sometimes I for current or for ampere. So they also write it as capital A. So these are the fundamental dimensions. If you see previous year's NEET question papers, you can see that how this type of questions has taken place on basically this type of fundamental quantities. Now obviously in NEET we have to go for some various type of questions. So one of them will be starting from directly on the concepts of basic dimension, and all the materials you can see of us, and all the other things like you can see the textbook you are following for NEET preparation already. You can see there are some charts. Those charts are carrying some dimensional quantities, and now as you have completed your class 12 and some of you are in class 12 focusing NEET 2021, so you are definitely eyeing on a success, and whenever you are focusing to your desired medical rank, so we need to hard work a little bit far greater than what we did before. So the board preparation and the entrance preparation is completely different. So if it is difficult, still we have to do it. We have to memorize the dimensions, because because sometimes I can show you because I don't need to remember. But for exam time, you will face 45 questions for physics, 45 questions for chemistry, and 90 questions for biology. Oh, that's great. So 180 questions we will be facing in just 180 minutes because of 3 hours. And in the 3 hours, take at least 10 to 15 minutes time for the official protocols and signing, registering, attendance, these, that, exam hall, filling, and all these. So actually you are answering 180 questions in less than 180 minutes, within 160 to 165 minutes. So per question you have to you are getting a time, you have to solve per question within an interval of less than 1 minute in some seconds. So if we spare times for calculating the different quantities dimensions, so it will be in vain. So ultimately we have to remember some of the dimensions which are so common and which are so much usable in different cases. Now suppose in any time you are asked that what is the dimension of resistance. I'm asking a simple thing, like some quantities we use frequently in every cases of physics, but every time we should remember that this should be our ultimate goal, to remember all these basic dimensions, like very popular dimension, not basic like mass, length and time, but the very popular terms in physics. Like if I ask you the dimension of power, if I ask you the dimension of pressure, if I ask you the dimension of resistance, if I ask you the dimension of potential difference, if I ask you the dimension of capacitance. So these are all common questions. Now suppose if I have asked you the dimension of pressure, so pressure I can write it like this, or even you can write it in full words, that dimension of pressure would be what? It has to be force by area. So when you are writing force by area, it has to be ml t to the power minus 2 by L square. So finally it is coming ml to the power minus 1 t to the power minus 2. So it is like the dimension of pressure. Now when you are discussing dimension of pressure, as we are going for NEET or any competitive exam, we need to remember there are some quantities which are having same dimension along with pressure. So what are those quantities? First of all, from the elasticity chapter, the chapter of bulk modulus, you know it, that bulk property of solid, that stress and the all elastic moduli, all the elastic modulus, like Young's modulus, like rigidity modulus, you can say for bulk modulus, all the elastic modulus, they have the same dimension with that of pressure. Just like if I ask you the what is the dimension of work or energy, what is the dimension of work or energy, if I ask you like that, so dimension of work or dimension of energy is actually nothing but, we know that force into displacement. So the dimension of force we all know ml t to the power minus 2 into the displacement's dimension is L. So finally the work or energy have the dimension ml square t to the power minus 2. So simply this is the dimension of work done. But whenever you are in the field of the competitive exam, this is not enough. So you know that the dimension of work done is or energy is this. Apart from these two, there are two more quantities which are having the same dimension as work or energy. What are those two quantities? Number one, moment. Moment means force into perpendicular distance, and the second thing is couple. Couple's moment, that you know, that is called torque. So moment of the couple is known as torque. So moment and torque, they are having same dimension, same unit, Newton meter, while the work done is having the unit called joule. Just to differentiate between our simple idea that moment and torque, these two are vector quantities, and work done and energy, these two are scalar quantities. So basically the scalar and vector quantities we have discussed here, they might have same dimension, but they may be represented as either scalar or vector. Now from here, one thing we must focus, that suppose in any question it is asked that Planck's constant, like this, Planck's constant is dimensionally identical. Planck's constant is dimensionally identical to which quantity? Suppose it is the question that Planck's constant is dimensionally identical to which quantity. So everybody will go for what? Everybody will surely be going for the four options will be there. But at any time, whenever this question will be there, you just go for like this. You know that MVR equals to NH by 2 pi from Bohr's postulate. Now, if MVR equals to NH by 2 pi, then simply MVR, this MVR is what? It is angular momentum. It is angular momentum. So if it is angular momentum, then h by 2 pi, this part h by 2 pi is actually a simple number, because h is Planck's constant and 2 pi, they are all numbers, but n is principal quantum number. So n by 2 pi is actually dimensionless. This part is dimensionless. So MVR, that is the angular momentum, and should have the dimension ml squared, because mass m, velocity is L t to the power minus 1 and r is L. So ml squared t to the power minus 1. This part is dimensionally equal with h. So whenever you will be asked that angular momentum is having the same dimension with which quantity, it is undoubtedly Planck's constant and vice versa. So in any question, if it is asked that Planck's constant is having the same dimension with which quantity, so don't look into any other option except it is angular momentum. So for this type, these questions are we should not be dealing with in calculation during the exam time, because it will kill our time. This will be time killing question. So this type of questions we have to memorize every time. Okay, I have to reconnect. This is angular momentum and this should be identical in dimensions with Planck's constant. So this kind of reconnection, this kind of connection we have to make during our exam time answering. Now from here you can be asked that you know about force constant, right? So you know that F equals to K delta L. We have learned it in elasticity. So they have asked that the force constant's dimension. So force constant's dimension is force by length. So it is simply ml t to the power minus 2 by L. So it should be mt to the power minus 2. So basically it is what? It is the dimension of force per unit length. So they can ask you that which of these four options is actually equal. Which of these four options is equal in dimension with the force constant? So what can I do? There are four options. We have to check with everyone's dimension. No. This will be only equal. This will be only equal with the only one quantity in this world, that is called the surface tension. That is called the surface tension of any fluid. That is on the superficial portion of the fluid surface. That is the uppermost area, and on the uppermost area we will have the surface tension as how much? That is mlt to the power. You know that very well. If this is the liquid surface and if it has definitely a certain perimeter, so force by that perimeter is surface tension, you know. So surface tension is basically surface tension and force constant, they are dimensionally identical. So I am writing it here. Surface tension is dimensionally identical with force constant. So this is a very important idea for us, and whenever we have this, that surface tension is identical in terms of dimension with force constant, and we have to remember that this type of questions are hot favorite in every year. Every single competitive question, whatever it is, state joint entrance for engineering or all India joint entrance or all India medical entrance like NEET, for all type of exam, this type of questions are important. Now suppose they are asking you one certain type of question, that is what will be the dimension of this quantity? What will be the dimension of this quantity is matching with? Let it be, there are four options: force, pressure, velocity, acceleration. So it's a simple question there, that what will be the dimension of these quantities matching with which of these quantities given in the four options. So here I can find out this quantity's dimension and I can match it with anyone. If you do it like this, y is Young's modulus and rho is the density we know. So if we do it, it is how much? It will be Young's modulus means we already discussed that elastic modulus. This Young's modulus is having the dimension of pressure. So it is m L to the power minus 1 T to the power minus 2 and density is mass by volume. So it is ml to the power minus 3, its whole to the power half. So finally mm going out, it is L to the power square on up and finally it is LT to the power minus 1. So you are finally getting this as LT to the power minus 1. So it is definitely, it is going to be the velocity. But now as you are a student who is aspiring for NET, so when you are aspiring for NET, we must be a little bit precise, we must be a little bit tricky and we should be smart with our answering. So whenever we are answering this if it is expected from a class 11 student who is first joined in class 11 science, then it is expected from him or her. But when you are aspiring for NEET 2021 and already we are on the boat for traveling towards the destination, so we must be a little bit smarter in our approach. And how we can do it? There is a simple solution, that whenever we are thinking this type of situation, try to reconnect with the other chapters of your syllabus. There are so many chapters in your content that you have successfully studied in 11-12 level. Now remember, dimension is a bridge between all the chapters, because in all the chapters there are so many known and unknown quantities with different dimensions. Now if we can identify those dimensions and how they are connected with the other quantities, then we can easily find out that what is it trying to say. Remember the velocity of sound in any medium. Remember the formula for velocity of sound in any other medium, that was used in Newton's formula, and for air or gases it was rectified by Laplace's formula. If you can reconnect with that, you can remember that the velocity of sound in air was having initially this formula, that was the bulk modulus of air by density under root. Now the bulk modulus and Young's modulus will be having the same dimension. So this is actually velocity. So without any calculation, you can go for the right option, and that is velocity. I hope it is clear to you that what I am just trying to say, that you can save your time. You can very possibly, and it is very feasible, that we must save our time, because we have to answer each question in less than 1 minute time, and it is not possible to answer all the question in less than 1 minute time. So some question we have to be so sure with seeing on it. We can't go for detailed calculation for those type of questions. We have to go blindly on it, because we have to be that much confident for this type of questions. So for this type of questions, if you spend your time on calculation, that will be your drawback. So we have to be fighting out these problems. We have to be precise. We have to make it a simple thing. We have to make it a KISS. That means, that is, keep it short and simple. This is the mechanism of NEET. This is the mechanism of NEET success, that keep it short and simple. We must not be elaborated. It must not be a very long time taking process we are following. So we have to be that much precise, and we have to be that much proficient with our answering. So now we are going towards the next question, which is another important type, that is, suppose you are given a situation. So you all know this equation very well from ray optics, that is mu equals to a plus b by lambda square. That is, mu equals to a plus b by lambda square. We all know what does it mean, that mu equals to a plus b by lambda square. This is called the famous Cauchy's relation. Now we all know that lambda is the wavelength of light, and a and b are two unknown parameters, and we have to find out the dimension of a, dimension of b, and they can ask you the SI units of a and b. This can be also asked, that the SI units of a and b. Either they can ask you the dimensions of a and b, or they can ask you the SI units of a and b. So from here, how we can do it? See, this a plus b by lambda square, and it makes mu. What is mu? It is refractive index, and we all know that refractive index is sin I by sin r. And if we take the ratio of two trigonometric functions, that should be a unitless dimensionless quantity. So mu is not having any type of dimension. So it is m naught, L naught and T naught, m to the power 0, L to the power 0, T to the power 0. That is the dimension of mu. Now you can see, if I go for dimensional homogeneity principle, what was dimensional homogeneity principle? We know that is dimensional identicality or dimensional correctness. An equation, whenever we are writing an equation in science, that equation must be correct in both ways. That means from left hand side and from right hand side in one aspect, that is the equation's dimension on both sides has to be same. First of all, it either can be a plus minus b or c plus minus d. It's a linear equation. If this is a successful equation, both of the side of the equation must have same values, same numerical values at a whole, and they must possess the same dimension. And it is only true when you are adding two quantities or subtracting two quantities. It is only possible when you are playing with some identical quantities. So if this kind of linear relations will be given, we know we can segregate it by this manner. So when we can write this whole thing, see, all are additions and subtractions, but additions and subtractions on whatever be the side of the equation can only be done between two identical quantities. So a plus b, if you can do, that means a and b are with the same dimension. If you can subtract c minus d or d minus c plus d or d minus c, whatever you can do, but that is totally dependent on their dimension, because addition and subtraction can only be done in terms of identical dimensions. So whenever we are representing this, we must have to be ensuring that this equation is only going to be true if a, b, c and d, from this equation all the individual terms must have same dimension, and this is called dimensional homogeneity. Homogeneous means same, identicality. So dimensional homogeneity means all the individual terms of an equation, the single individual terms of any equation must be having same dimension on both sides. Now from here, what we are looking for, that mu equals to m naught, L naught, T naught, that we know very well. Now here, that mu is the sum of a and the whole thing. So definitely this mu is dimensionally identical with a, and that means it is dimensionally identical with b by lambda square. And what is lambda? We know from Cauchy's relation, lambda square should be L square, because lambda has the length dimension. So lambda square is L square. So this will be ultimately b by L square. So b by L square is having the same dimension with mu, and that is m to the power 0, L to the power 0, T to the power 0. So dimension of b, it should be L square. So this is what happening for the unit C. A is having no dimension, m to the power 0, L to the power 0, T to the power 0. For b it is L square. So if I go for the SI units, so for A, the SI units, that should be unitless because it is not having any dimension. For B, this will be L square. And what is the unit of L square in SI system? That has to be meter square. So these are the different values, different relations we can make from the principle of dimensional homogeneity, right? So if anytime you are asked that what is the dimension, can you tell me any quantity among these four? There will be definitely four options in NEET. So there will be four options, and you will be asked that which of these following quantities having unit without dimension? Which of these following quantities will be having unit without dimension? This will be a simple question to ask anytime in any competitive exam, and even it is so easy. Now that will be a very simple question, that in our universe, in our world, there is only one quantity which is having unit without having dimension. What is the unit having dimension? That you know very well. If I think about a circle and its center, then this is the radius and this is the arc length S, which is making an angle theta. So if we know that trigonometrical formula, you surely know it, S equals to r theta, then we can write that angle is what? Angle is arc by radius. Now see, arc by radius. What is arc here? Arc means the dimension of length because it's a part of the perimeter or circumference. Radius is definitely the dimension of length. So when we take the dimension of the angle, it is length by length. So ultimately it is coming as m naught, L naught and T naught. So which is dimensionless. But though the angle is dimensionless, can I say that it is unitless? Never, because we know the unit of angle is what? Unit of angle is degree in our practical sense, radian for SI unit. So it is a single quantity. It is the only lone quantity of this universe which is having unit without having dimension. And yes, apart from this, for 3D system there will be steradian. Steradian is the unit of solid angles. For solid angle is also a kind of this, so it's ultimately related to angles. So if this type of questions are there, that which of the following quantities, which of these following quantities is having unit without even having dimension, the only answer will be angle. If angle is not there, it will be solid angle, no issues. So now we are well inside the chapter. We are dealing with the dimensional identicalities or homogeneities and the basic dimensional applications. So from here we are going towards different types of questions which is based on dimensional homogeneities. So from here we are going for a next question, and kindly write down this equation what I am writing on the board. It is so important for every one of us. If I write this, F equals to AT plus BT square. So here surely F means force and T means time. So we have to find out the dimension of A and dimension of B, whatever dimension of AB, and whatever we have to find out dimension of A by B. So this is the question asked from this particular equation, F equals to AT plus BT square. So we have to find out this AB and A by B. So from here what we need to focus on, that is force is equal with these two factors. Now if I follow the dimensional homogeneity from here also, it clearly says that the dimension of force is equal with AT, that is A into T, and obviously the dimension of force is equal to BT square. Now what is the dimension of force? We know the dimension of force is mLT to the power minus 2, which is equal to A into T. So dimension of A is mLT to the power minus 3. This is the dimension of A. Now here again mLT to the power minus 2 equals to B T square. So finally the dimension of B will be ml T to the power minus 4. These are the basic two questions we have successfully solved. But from here we need to solve some other questions, right? AB and A by B, which is so simple that AB will be the simple multiplication of these two, that m into m it will be m square, L into L surely it will be L square, and T to the power it will be minus 7. T to the power it will be minus 7. So this is one answer we have successfully done. Now it is A by B. If we do A by B, what is A here? ml T to the power minus 3 and divided by ml T to the power minus 4. So T to the power minus 3 divided by T to the power minus 4 is go up. So ml cancels out. So it will be 1 by T to the power minus 1. So it is T only. So these are the four questions, four sub-part questions we have solved from this particular question, which is actually related to this particular question. Now from here we can solve more questions on this. We are the class of NEET, so we have to be so much versatile of different types of questions and answer. So let's take one very important question which is so common also, like we can say from here, that is suppose x equals to lambda t, where x is a quantity that is what we don't know now till now, and t is definitely the time, and x is some a quantity, and to know about x we need to know this equation, that x equals to 1 plus 2 by factorial 2, 2 square by factorial 2, 3 square by factorial 3, plus 4 square by factorial 4, and so on. So this is about x, and that x equals to lambda t. So the dimension of lambda is matching with which quantity? Number one, dimensionless. Number two, time. Number three, frequency. And number four, amplitude. You know what is amplitude of any waveform? That amplitude means the maximum displacement of any vibration or the maximum displacement of any waveform. So we know about this. Now how we can solve it? It's a very important question to all of us. See, for this particular question, x is lambda t, and that is the key factor. So I will use it later. First we need to know about the actual identity of x. So what is x basically? You can clearly see it's a series of real numbers. So x is 1 plus something like this, and these all are numbers including 1. So when you are adding all these numbers together, then they are continuing up to infinity, we never know. So all these individual numbers we are adding up. So they are having, according to the principle of dimensional homogeneity, all the terms of this particular equation individually, they are identical to x in terms of dimension. So, and each of the terms are dimensionless. That means each of the term is having a dimension m to the power 0, l to the power 0, t to the power 0. So finally x becomes a quantity because it is a sum of all non-dimensional quantities. So the sum of them will surely be having no dimension, and that is m to the power 0, l to the power 0, t to the power 0. So x should be m to the power 0, l to the power 0, t to the power 0 in terms of dimension. So x, we got that x is a dimensionless quantity. But was it our asking? No, this was not asked in the question. What was asked in the question? That lambda's dimension, the dimension of lambda is matching with which particular quantity in the given four options. So from this particular equation you can write here that x equals to lambda t means that x equals to lambda t, that means dimension of x is what? M0 L0 T0 equals to lambda into t means time. So t is going on this side, m and l has no effect. So dimension of lambda is t to the power -1, or you can write 1 by t. And 1 by t, you know all the thing, if t is the time period, 1 by t is the frequency. So lambda is matching with this answer, that the dimension of lambda is matching with the dimension of frequency. It's a so important question, and we must know that this type of questions are always important for our NEET exam. Now from here we are focusing on the next problem, and the next problem is surely on the basis of again a dimensional homogeneity. So let's write a very common equation that is called the van der Waals equation, P plus A by V square into V minus B equals to RT. You can clearly see we are doing with the 1 moles gas. So in the dimension, if you don't use mole, that is not going to be a big issue, because if it was n mole, it would have been an by n square Vn square, you know it better. So you are asked that what will be the dimension of A and what will be the dimension of B. So this is a very important question, that what is the dimension of A and what is the dimension of B. So that is a very important question for this particular section. So how we can solve it? It's such an easy equation that in the left hand side you can see two terms are getting multiplied. So don't be tempted and don't do multiplication with removing the brackets. You can clearly see that this quantity B is subtracted from V, the volume. B is subtracted from the volume V. So V and B is surely having the same dimension, and that is how much? That is L cube. So from here we get the one answer readily, that is V equals to, ultimately V stands for L cube. Now from here, what is the next thing we are going to do? That is such an important issue, that pressure and A by V square. So pressure and A by V square, as they are added up, so addition is there, means addition can only be done between two identical quantities. So pressure and A by V square is surely having the same dimensions. So if we do it like this, pressure is having ml to the power minus 1 t to the power minus 2 equals to A by V, means L cube. So V square is L to the power 6. So ultimately the dimension of A will become ml to the power 5 t to the power minus 2. And in some textbook, if there is in place of L cube, it is given by L cube mole inverse, no issues. They are not taking 1 mole, finally they are taking, it is for 1 mole, so an L cube mole inverse. Here also they can write ml to the power 5 t to the power minus 2 mole inverse. So these kind of things are always there and we can't neglect it. It is always there, we can't avoid it. Okay, so from this type of things we need to move around a different case, that is Boltzmann constant. We need to know about Boltzmann constant's dimension. So can you tell me about, if you can write it to us, that Boltzmann constant is actually R by N. N is stands for mole, that is Avogadro number, you know. So it's R's dimension. R is what? We know that PV equals to RT for 1 mole. So R is simply PV by T, and N don't have any dimension, so we are removing it. Here PV means pressure and volume, ml to the power minus 1 t to the power minus 2 into L cube. And what will be this T? This T is nothing but the temperature, so I am taking it as theta. So finally it is becoming what? It is ml square t to the power minus 2 theta to the power minus 1. Ml square t to the power minus 2 theta to the power minus 1. This is the dimension of R also, that is ideal gas constant, and the dimension of Boltzmann constant also, and this is highly important for different sectors. We are going to use it. Now suppose anyone asks you about the dimension of potential, which is also another important issue. We know from electrostatics, you have just studied in class 12, you know that even in class 10 you studied about potential. You know that energy or work done equals to charge into potential. So potential is always work done by charge. So dimension of potential is m L square t to the power minus 2 by IT. So finally it is becoming ml square t to the power minus 3 I to the power minus 1. So this will be the situation. Now from here one thing we should notice, that this is the dimension of potential. Then what will be the dimension of resistance? That is potential by current. So this is going to be the dimension of resistance, that ml square t to the power minus 3 I to the power minus 2. Now from here we need to know about a very important idea, that is, suppose one equation is given to you, I equals to Is, where I and Is are the current dimension, electric current, e to the power means exponential, it means e to the power EV by eta kt minus 1. EV by eta kt minus 1. Exponential means e to the power. So this is actually what? E to the power EV by eta kt. Now this E is the exponential, but this E is the charge of an electron. This we need to be clear with. Here the T stands for temperature, V stands for voltage or potential, and K stands for Boltzmann constant. So why I am telling all this? Because in exam time they will not say anything. They will say only E is electronic charge, V is voltage, and like this, and they will ask you from this equation what is the dimension of this eta. And don't get confused, and now I am telling that without calculation you can write something, but it is not true for all type of questions, right? So eta can make us so much confused, because in some question eta is what? Eta is coefficient of viscosity, and we all know that is having a dimension, this one. But in this question it can never be the coefficient of viscosity. It may have some names, it is having a name, diode quality factor, but we don't need it. We are simply asked that what is the dimension of this eta. So how we can do it from here, that what is the dimension of this eta, that how we can do that exponential something, that is e to the power something minus 1. Now this part is current, and current, they are dimensionally equal. Now it is obvious that when already current dimensionally equal, so this part must have no dimension. That is why current's dimension will still exist, because if this entire part is having some dimension, then definitely current's dimension will be altered, will be changed, so it will never match with this one. So this part has to be, this entire things in bracket has to be dimensionless. This has to be dimensionless. Now if this minus this is dimensionless, then individually one is a number, this has to be a number also which is dimensionless. So now exponential e to the power something, see very carefully, e is a number, and if it is having no dimension, that means EV by eta kt, EV by eta kt is also having no dimension, which is m naught, L naught, T naught. So we don't need that eta here, that is the coefficient of viscosity. We don't need that eta here. So eta becomes what? So eta here is actually EV by kt into m naught, L naught into T naught. Now the important thing is that here the T can be confusing us. So we already done it before, that what was the electronic charge dimension? Charge means I into T. Here K means ml square T to the power minus 2, and K, there was a temperature dimension theta to the power minus 1. T is the temperature, so is theta. And what about potential? Is work done by charge, so it is definitely ml square T to the power minus 3 I to the power minus 1, and you don't need to multiply this here. So finally what is coming? See, theta are going, m are going, so either it is IT inverse is going, T to the power minus 2 will go up, so finally it will be coming as m to the power 0, L to the power 0, T to the power 0. So the diode quality factor, I told this eta is becoming dimensionless also. So this kind of questions are always there, and we need to know the simple idea that dimensionless factors we have to include in the discussion, and we have to include by this type of calculation. Like this type of question we can see here also, like anytime it is asked that within a capillary tube mercury rises up to a height h, which is equals to 2s cos theta by r rho g. H equals to 2s cos theta by r rho g, where you can see that h is the height rise, r is the radius of the tube, rho is the density of mercury, and g is the acceleration due to gravity. So definitely the asked question is what is the dimension of S, and S, if it is not mentioned, we surely know from the Jurin's law and capillary action of a liquid from surface tension that S is the surface tension here. So if we want to calculate it, sometimes we may forget, so S dimension will be what? Force by length, that is mt to the power minus 2. So here how can we do it? Just for one instance I have taken this example because of this cos theta. Cos theta is a trigonometrical function, so we can't put its dimension there. So it becomes like what? That S becomes h r rho g by 2 cos theta. Now 2 cos theta simply a number, so dimension of S is actually dimension of H R rho G. Now H is what? L, R is what? L, M is LT to the power minus 3, and G stands for M LT to the power, it is acceleration, so LT to the power minus 2. So finally it is coming what? It is coming like L's are going, and it is mt to the power minus 2, which we done before in the class also regarding force constant. And I told in the universe force constant is only dimensionally equal with one thing, that is called surface tension, that is force by length. So this type of questions are always there, we can ask this type of, which can be asked this type of question anytime. And even you, when going through the practice question, you will go through the exercise, we will go through the multiple tests we are offering in the site. You can see that how many times these questions are changing. Now one thing for here, the next question we are switching towards, suppose in any measurement system, in any unit system, force, area and velocity, force, area and velocity are taken as fundamental dimensions. Force, area, velocity are taken as fundamental dimension in place of MLT. So we need to find out the dimension of mass, we need to find out the dimension of pressure, we need to find out the dimension of energy, and we need to find out the dimension of impulse. So these are the questions we are looking for this particular situation, when force, you can see F for force, A for area, and surely V for velocity. So we want to discuss that force, area and velocity are fundamental quantities, and we will be finding out these quantities from this. Now see very carefully, force, area and velocity are used as fundamental quantities, but if you want to have pressure, if you want to have work done or anything, we must need to know the main fundamental quantities on which all the other quantities we can build. So the main fundamental quantities are mass, length and time. So we need to know how mass is looking like in new measurement system, how length is looking like in new measurement system, how the time is looking like in this new measurement system. Now mass or length we can write it, see area means normally, area is actually you can write length into length. So when you write area, in terms of dimension, area is length square. So in this system, this L becomes a to the power half. So L will look like a to the power half. And what about T then? We know that velocity is actually displacement by time. So if I write V, that is actually L by T, right? That is actually L by T. So T will be simply L by V. So L is a to the power half into V inverse. So this will be the times dimension. What I get? A to the power half into V inverse. This will be the time dimension. And what about the mass? Mass, how can we get? That is a very, very important idea. Here we are having pressure, we can have energy. So how we can get mass? That is very, very important. See, we have velocity, we have force. If we do force by acceleration, we can get mass. But for acceleration, how can I get acceleration? Mainly the acceleration dimension is what? L t to the power minus 2. Now what is L here? L is a to the power half. Now T is what? Here T is this one. So it is a to the power half v to the power minus half to the power minus 2. So acceleration becomes what? So if I multiply this, a to the power will be minus 1. So it will be simply a to the power, this will be minus 1, and half minus 1 is minus half, and this will be v. This is the dimension of acceleration. Now you see, if it is the dimension of acceleration, now we know that dimension of mass is actually dimension of force by dimension of acceleration. Now dimension of force is intact because it is given as the fundamental quantity. So it is dimension of force divided by a to the power minus half into v. So it becomes f a to the power half v to the power minus 1. So this is the dimension of mass, this is the dimension of length, and this is the dimension of time in terms of f, a and v in the new unit system. But look at the question, anything we solved? Yes, we got solved with the mass. It is f a to the power half v to the power minus 1. Now what about pressure? For this we really don't need to do much calculation because pressure's dimension is actually force by area. So what is area here? Dimension is given as a. So it is f a to the power minus 1. So no issues. It is f a to the power minus 1. What about energy? If we think about the energy's dimension, what about energy? Energy stands for work done, or energy stands for work done, or half mv square mgh. That is ultimately force into displacement. So force into displacement means force into length. So what is the length dimension here? A to the power half. So finally we are getting what? We are getting this one, f into a to the power half. This is the dimension of energy. What is impulse, guys? Impulse is actually, impulse means the change in momentum. Impulse means the change in momentum. So whenever you are taking the change in momentum, means you are subtracting final minus initial momentum. So change in momentum will have the same dimension, that of momentum. Change in momentum will have the same dimension, that of momentum. So it should be mass into velocity, and we got know the mass is how much? Mass is f a to the power half, and obviously v to the power minus 1, f a to the power half, v to the power minus 1, and finally it is becoming as velocity. So energy, when we are writing in terms of an impulse, we are writing in terms of force into time or change in momentum. We can write it in terms of impulse means force into time also. So when we can write change in momentum, or we can write into force into time. So force into time, we got time like this. So force is ultimately f, and time is a to the power half v to the power minus 1. See, we are getting the same result in both the cases. So force into time, that is simply the moment impulse or the change in momentum. So finally we have done all these questions. So where the fundamental quantities are shifted, fundamental quantities are shifted to another different quantities which are actually not fundamental quantities, they are derived quantities, but we are working them as they are fundamental. So from this point of view, basically from this point of view, we are doing it what? That we are basically doing relation, we are forming the relation, establishing the relation between the dimensional quantities and non-dimensional quantities. So here we have done up to, we haven't done the error analysis or the dimensional analysis, we do in the further classes, but here we have successfully completed the basics of dimensional application, that units and dimension is starting with our NEET syllabus, units and measurement. So stay tuned, we will be back very soon with this continuation with the dimensional analysis and theory of errors. Keep liking and subscribing our channels, get registered, there are plenty of opportunity left for you. Join us and feel the difference. Now I am signing out, Rahul from Mocktest4you. We'll be meeting very soon.